Hello and welcome to my workbench. On the bench today we have a SPI voltage meter. Right, this is what you call a high voltage pipeline inspection meter. Right, what this does is this is used to test the coating on pipelines, like industrial pipelines. Right, has a name in client Pipeline Inspection Company Limited. This is a SPI. It's a model 790. Right, it uses this 12-volt battery. Right. So what I'm going to do today, we are going to see if we can repair this meter and perform a calibration. Right. What is the complaint with this meter is that it is not working. Right, it's not outputting the voltage. This can range from anywhere from, I believe, 15,000 volts. Right. Let me double check that. I'll get back to you. I'll get back to you on that in a moment. Right. So let me double check that, and I'll be back. Okay, I'm back. Okay, I just double checked the information on this. The voltage range on this piece of instrument is from 5,000 to 35,000 kV. That's DC, pulse DC. Right. So from this 12 volts, it steps it up via transformers built in here, from 5,000 to 35,000 kV. Right, this is the on-off knob. Right, when you put it on, there's a small set screw here, adjustment. Let me see if I can zoom you in onto that. Right, just 1 second. Focus now. Come on. Right. Yeah, here we go. Right. Right, there is a small set screw that goes here, and you could adjust the potentiometer inside it to give you the different ranges of volts, and you will get a readout on the display of the set voltage. Right, so today we are going to attempt to fix this unit, and it's not working. Right, so without further disruption, let's get into it and dismantle it. Alright, first we're going to take off this handle here. It's a little tricky to take off. Bear with me. It just lifts out, it comes out like this. Alright, so I'm going to zoom back out. Yeah, that should do there. That should do fine. Alright, so in order to get into this, what we have to do, there's a number of screws here. Right, but you don't need to take out all the screws, only 1, 2, 3, 4, 5, 6, 7, 8 screws we need to undo. So let's get to it. Okay, one other thing we need to do, there's a pin that goes here, we need to take out that pin. There we go. And the pin is out. This is the pin. It's a roll pin. And it's supposed to just pop out like this. There we go. Alright, as you can see, the bottom is already out. Okay, these are the two terminals for the battery connection. This battery actually slides in like this and goes over, and clips on here, and the two terminals touch here. Alright, so let's undo these. Smells like something is burnt inside here. Really has that electronic smell, like in something burnt, component burnt. So what I'm going to rest the parts in here. All right, rest this aside. Rest this aside. And the battery, let's leave that up on the side here. Okay. As you can see, this is a rubberized coating, a mat they put over the electronic board. So we're going to remove this. Stuck down. Very carefully remove this. Okay, here we go. All right. Yep, definitely something burnt inside there. Alright, now as you can see, there are some screws, two small one here, three big ones, and a plastic screw here. Alright, let me see if I can get in there. Alright. Yep. This is my right. Here are the screws. There's one here, two small one here. This holds down the speaker. Well, it's not really a speaker, it's a piezo. There are three big ones, 1, 2, 3, and there's a plastic one under this cord here. Right, that don't need to be removed. That is just holding down the components. So what we'll do, we'll try to remove this by pushing on the knob here like that, and it comes out. Now be very careful, because this wire is run straight down to the terminal. So just take this, run around like that, and we are out. Okay, let's talk a little bit about what's inside here. Now you see, okay, now you see there's two wires here on both sides. One is run to here and one is run to here. Oops, sorry, you're not seeing that, are you? Silly me. Yeah. Okay. All right. One is run here from the circuit board transformer. This is a large transformer, and this is the other one, right, which is the ground. Right. How this, I forgot to mention that attached to here is a ground cable that trails on the ground. Right. Here there is a small extension that goes on here with a spring, a big spring to fit around the pipe, right? So that goes in here, and once the voltage is present, it will ignite a spark, indicating what they call a holiday. No, not a holiday like not a holiday like a public holiday, but a holiday as in porosity. Okay, so without further ado, let's look at what we have here. Okay, right, this is the main output transformer here. This steps the voltage from 400, right, to a 5,000 to 35,000 kV pulse, right? So basically we end up with about 400 volts around here from this transformer, and this takes that voltage and steps it up to 5 to 35,000 kV, right? This is the display. This is the voltage selection knob. I mean the on-off knob, sorry. Yes, this is the on-off knob, and this is the potentiometer, at which adjusts the voltage selection switch, the output current, not the output current, the output voltage, sorry. Alright, so let's have a look and see if we see anything that is burnt, because it smells very high. And under here there is no components, so all the components are top side. It is a double-sided board. There's two boards. This is the display board, and this is the preamplifier board and the output stage board here. Alright, there's some MOSFETs on this side, some power MOSFETs. Alright, so what we can do is try to separate these two by slackening these 3 plastic screws. Like so. And we can just remove this board. It's held on with some via some connection pins, if you can see here. Yep, there we go. There are pins here, and there's some more pins here. These are some standoff posts, plastic standoff posts. So what we'll do is just lift this off so we can separate the boards. And like that. And there we go. I don't see anything burnt on top of this board, so I guess nothing is wrong here. And alright, so what I'll do, I'll get the camera repositioned and we'll have a look at the board. Alright, so I'll be back. Okay, I'm back again. Alright, so now we are looking at the board. Alright, there's a lot of cups here, here. Got one over on this side. Not seeing it there. Right. Can see it better there. Good. And there's quite a few transistors on this board. Wow, there's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Could be around 19 to 20 transistors. Right. Okay. All the MOSFETs, everything looks fine. No burnt resistor, but there's something smelling like it's burnt. Okay. If you can see here, there's a small resistor that looks like it's, oh man, small resistor here that looks like it's burnt. You can see there. Sorry for the wobbly camera there. Let me see if I can get it to focus. There it is there. Let's see if I can probably zoom back out and put the camera a little closer. Come on, focus. There we go. Right, you can see there. Some reason it's picking up the background. There it is. It's a burnt resistor. And so let's see if I see other components. Oh, look at this. It's a burnt transistor. Yep. That's what the smell is all about. This burnt transistor. Right. Oh, it's cracked. Okay, I'm going to remove it and see if I can make out the part number. Alright, I'm going to test this resistor and see if it's open, shorted. Alright, and what we will do is test the components around this transistor and around this resistor and see if anything has blown. Alright, so I'll be back. I'll just get those components out and we'll check it. Okay, I'm back. Okay, I got out the two parts. Alright, what I will do, I'm going to put this under the microscope so I can see if I can make out the numbers. Alright, so 1 second. Okay. It looks okay. 78L05A. Okay, 78L05. This tells me this is a voltage regulator. Alright, a 5 volts voltage regulator. Alright, and this is the resistor. See the burnt scotch mark there. So the value of this is red, white, brown, gold, red. So 290 ohms. I believe red is 2% tolerance. Alright, so what I'm going to try to do is get both shots into the picture here. Here we go. So what I'm going to do is bring my meter into the camera. And see how much that measures. So 19 ohms. 19 ohms. 19 ohm doesn't look right. One nine. Is that a black or a brown? Oh, yeah, it is a black. Oh, that's happened when you get an old. Yeah, I say it's that go. So it is red, white, black, gold. So is it red or brown? Huh. It look red to me. Yeah. It could be brown. Under the blue looks like red. What is say 19 ohms on the meter. 19 ohms exact. So if this is brown, it'll be 1, 9, black is 0, it would be 19 ohms, which it is. So that's measuring okay. It's just discolored, but it's okay. Alright, so that with that. And as for this voltage regulator, I think I have one somewhere around. Let me check my parts bin. By the way, that's my parts bin over there. Yeah. Okay, yep. Yes, I do. Okay, we're back here. Okay, here we go. 78L05. Probably can't see it in the camera that well, but take my word for it, it's the same thing. See how this one is cracked. One of the pins came off. Alrighty, so what I'm going to do now, I'm just going to check around and see if anything is shorted in the same tract. So I'm going to leave it in ohms. One part goes to this resistor here. $4.7K. Yep, you can see that a bit better. Okay, that's this one here. Yeah, 4.7 k ohms. So that is okay. Then there's this tantalum capacitor here. Capacitance. It's not shorted. It's not shorted. This one goes to this resistor here. $14K. Okay, everything seems to be okay here. So diode here. Yep. Good. Check this other transistor right here. That's good. That's good. So it looks like only the voltage regulator is bad, but why would that be bad alone? What caused it to fail? So this goes to there, goes to here. So it leads up to this board. Yeah, you got a capacitor in line there. Alright. So what I'm going to do next is install back that resistor there. I'm going to see if I have a 19 ohm 2% resistor, and I'm going to replace this voltage regulator here. but if I don't, I'll probably use back this resistor. It seems to be okay. So I'm going to check and see if I get that resistor, and I'll be back. Okay folks, I've installed back the new transistor here, and I installed back a resistor here. I did not get a new resistor. I didn't have a 19 ohm, but I reused back the same one. So what I'm going to do now next, I'm going to reassemble everything and run a test. I'm going to show you the equipment I used to do a test on this and see if it works. Alright, so let's get everything back in its place. Be very careful. Oh, I forgot to trim off the leads here. Yeah. All right. So let's get back the plastic knobs on. These don't have to be tightened that hard. They're plastic. If you go to tighten them that hard, they are going to strip, and that could cause some problems. Alrighty. Okay. Now, in order to get back this where it's supposed to be, we have to install back these two wires. Right. So this will be going like this. This one will be going here. Alright, so this has to go through here first. I'm just going to remove this tape. Alright, so there's a long screw here. could be a little tricky to put in, but once you get the hang of it, shouldn't be a problem. And that's where the problem comes in. Alright, so secure tightly there. Okay, now we have to try to get this back in. This cord has to go over here like this. Oh, forgot to put in this too. Alright, like that. And there's a little piece of paper, cardboard that goes between here. And there we are, we're in. So you got the idea. So I'm going to finish reassemble it, and we're going to run through a test. Alright, so I'll be back. Okay guys, I'm back. So I finished assembling the unit. Everything is back in its place. So first thing first, we're going to test and see if it's working. Alright, so I have the unit on. This works with 12 volts. So I am going to set my power supply to 12 volts, 12.5, and current at 5 amps. Okay, and so I'm set at 5 amps. So this is a positive and this is a negative. When I put the power supply here, you will hear it start a beep. Alright, so here goes. The switch is on. Okay, let's check the display now. You can see the display there. Right now it's at 6.97,000 volts. Alright, let's turn that all the way down. Looks like that's the least it can go. $7,000. Let's try to set it up a little higher. So what I have here, this is a Tektronix P6015A high voltage probe. Right, this here is my test probe that fits in front of here. To release, press this button, comes out, goes in there. And this is the ground cable and goes in the handle like this. Right, so put the probe here, connect the ground to this cable here. And I'm going to use this battery. See what we get. So it slips over like this. Make sure it's off. Right. Connect the probe here. Right, so this is a 1000X probe. So I'm going to set my meter to 1000X. We're going to set it at 1000X. There we go. See, it's 1000. Take up some light. There you go. 1000. Alright. You can see better. So I'm going to put on the switch and we're going to see what the reading we get. Sorry for the shaky camera, guys. I am not getting anything. No output. So it's not working. I have to go back into it. Alright, so let me open it back and I'll get back to you. Alright guys, I'm back. As you can see, I have the unit dismantled. What happened, it was not working. I was not getting the output voltage, as you can see when I tried to measure it on the scope. Right, I did some more troubleshooting. Right, and I realized this up amp here, which is a, let's see if I can make it out, LF412CP, right, which is a dual up amp. It requires a positive and a negative voltage to run. When I measured, I was getting the positive 9 volts. However, on the negative volts reel, I was not getting any voltage there. So I did some more troubleshooting, and I found out that I got another voltage regulator that was bad. It is the same as the one that had been blown before. This one is the same. Let's see if I can get it close up. Probably if I put it under the scope, you'll see. Hold a minute. Alright, that was the first one that blew. This is the second one. So the part numbers are identical. Right, this one is completely blown. This one has slight crack in it, as you can see. See there? So I replaced it with another one, and got back my negative 8 volts. I mean my 9 volts and a positive 9 volts. Alright, so let's do a test and see what's going on. Okay. Yeah, positive, negative. Alright. Alright, we're going to look at the scope and see if we get our pulse DC. Alright, I have my power supply set at 12.5 volts at 4 amps. I'm going to put it on the power now. So the power is on. I'm going to switch on the unit. Make sure it's turned all the way down. Oh, there we go. It works. So set my voltage, time scale, and there is my pulse DC volts. Right now it's measuring 3800 volts. Hold on a minute. Well, yeah, volt peak, which is 3800 volts. So I'm going to raise the voltage. I'm going to adjust here. You will see this expands. Oh. So right now it's up at 37,200 volts. I'm going to drop it back. Now it's measuring at between 800 volts. However, my display is not corresponding with the meter. You can hear that tick 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 as the voltage that comes out through there. Now don't touch that, that's very high voltage. Right now that's 26,000 volts. And I'm drawing here my amperage of my power supply fluctuating between 0.3, 0.2 volts. So I have to fix this display, calibrate it back. I probably figured the up amp is bad. I figured the up amp here is bad. This up amp here. So I'm going to do some more troubleshooting and see if I get this display to read according to that. Alright, so let me do some more troubleshooting and I'll be back. I'll let you guys know what's the outcome. Okay.